Hi everyone. Hi everyone. This is Karini. Today I am going to present Human Assistive Devices seminar topic is Electronic Control in IBP Ventilators. Now see the introductions of IBP ventilators. IBP ventilator is nothing but intermediate positive pressure breathing ventilator or respiratory support devices used to assist or control the patient breathing by delivering pressurized air or oxygen intermittently. Electronic control system play a key role in ensuring the precise timing, pressure regulation and patient safety. Next, definitions of the IBP ventilators. IBP ventilator is a mechanical ventilation techniques in which a patient receives the positive pressure air during inspiration and exhale the passively, usually to assistive ventilation or delivering medications. Next, historical background. Historical background is nothing but in 1940s to 50s, first process involved in the ventilator developed. For example, Bird Mod 7. Early devices used the mechanical machines or a timing mechanism. In 1980s or 20s, in introductions of electronic control and microprocessor based system. In a present dates, intermediate positive pressure breathing machines are used digitally controlled and automatic alarms. Next, working principles of the IBP ventilators. There are two phases, inspiration phase and expiration phase. Inspiration phase is a ventilator deliver the air under the positive pressure. Expiration phase, patient exhale the passively to automatic pressure. Cyclic control, triggered manually electronically by a patient effort. Pressure flow and timing or electronically regulated. Next, black diagram overview. There are section and electronic control unit, feedback loop and user interface. Section is one of the section, air and water supply, valves, pressure and regulator, electronic controller unit, sensor, microcontroller and actuators. Feedback loop, monitor the airway pressure and flow, user interface and display and control panel. Role of the electronic control. It provides a precise pressure and timing control, reduce the mechanical wear and increase the accuracy. It integrates feedback loop or involved for the automatic adjustment, enhance the patient safety through the continuous monitoring alarm. Next, sensors in IBP ventilator. There are four sensors: pressure sensor, flow sensor and temperature or humidity sensor. Pressure sensor is a detect the airway and circuit pressure. Flow sensor is a measure the inspiratory and expiratory flow rates. Volume sensor is nothing but calculate the tidal and minute volume. Temperature or humidity sensor monitor the gas condition. It function is a convert the physical signal into the electrical signal for the processing. Next, microcontroller unit. Microcontroller unit is act as the brain of the ventilator. It collect the data from the sensor, processes and control the actuator. Execute the programmed control algorithm. Provide the communication with a display and alarm system. For example, ARM and PIC or embedded DSP monitor. Next, control algorithm. Pressure control, volume control and PID control and adaptive control. Pressure control is a maintaining the constant inspiratory rate. Volume control is ensure the delivery of the set tidal volume. PID control is adjust the system output to match set point. Adaptive control adjust the parameter based on the patient feedback. It goal of the control algorithm deliver the accurate and safe breath under the varying patient to the conditions. Next, timing and synchronization. Inspiration time TI and expiration time TE are controlled electronically. Trigger mechanism. There are three trigger mechanism: manual trigger, patient trigger and time trigger. Manual trigger is nothing but operator's start cycle. Patient trigger, sensor detect the effect. Time trigger, automatic cycling. Ensure the proper synchronization between patient and the ventilators. Next, actuator and valves. Activators involves the control airflow electronically. Rapid on or off switching ensure the smooth pressure transition. Stepper motor and servo motor may be used for the precise regulations. Valves respond to the microcontroller units common for the inspiration and expiration pressures. Next, power supply unit. Power supply unit is a convert the AC mains to the regulate the DC voltage, typically 5 volt, 12 volt or 24 volt. It includes the battery backup to ensure the operation during power failure. It produces or provide a overload and short circuit protection. Next, user interface and display. Display is a LCD or touch screens to the parameter, pressure, flow and volume control planner. Buttons are touch input for the mode selection and setting adjustment. Indicators, visual and audible alarm for the abnormal conditions. Next, feedback and control loop. Closed loop control monitor pressure and flow continuously. A deviation from the patient set point or deductor, the system autocorrect. Enhance the accuracy and patient control. For example, if the pressure exceeded the set limit value, valves open, pressure returns to the normal. And alarm and safety system. Overpressure alarm triggered if the airway pressure exceeded the safe limit. Next, low pressure or disconnect the alarm. It detects the lack or debuting disconnection. Power failure alarm. Alert stop if the supply voltage drops. Fail shape circuit. Ensure the patient can breathe ambient air out if the system fails. Next, mode of the operation. There are 3 modes: manual mode, automatic mode and patient trigger mode. Manual mode, operate the control inspiration manually. Automatic mode, microcontroller unit cyclic the ventilator automatically. Patient trigger mode, breathe start the based on the patient effect. Electronic control adapt the easily between modes via software configuration. Next, circuit design example. Input section, control section and output section. Input section is a sensor, output section is a derived circuit, control section is a microcontroller. Next, calibration and maintaining. Calibration is to ensure the patient accurate pressure and flow readings. Frequency performed a regular using reference instrument. Maintenance include the sensor cleaning, software update and alarm settings. Next, advancing electronic control. Microprocessor and DSP integration, real-time digital and signal processing, self-diagnostic and predictive maintenance, use of AI algorithm for the patient-specific control. Next, what are the troubleshooting arises in the IBBP ventilators? Common issues: sensor malfunction, electric fault, software error. Sensor malfunction, incorrect readings, electric fault, no power or unstable output. Software error is nothing but system freeze or alarm failure. Solution: perform a system diagnostic, replace the defective component, recalibrate the sensor. Thank you so much.